In this video, we're going to look at gradient graphs of exponential functions, in particular with base e. So if we look at the function here, we're going to plot the gradient against it. So when we see the red being plotted, that's going to be the gradient function. So you'll see this starting point that we've got here at x equals to -4. We see that the gradient is 0.02. And we'll see what happens as we run this animation plotting the gradient function. So you see, this is a very interesting function that what you will see in this function is the y values of the exponential are exactly the same as the gradient at that point. So you see here that we have the intercept 0, 1 here. The y value is 1, and you'll see that the gradient is actually 1 as well. We get to this point, the gradient's 1. Okay, and then you'll see that the gradient at x equals 1 is 2.7, and that's what it is on the function. So therefore, when you plot the gradient graph of an exponent of e to the x, the gradient function is actually just exactly the same. Okay, so therefore the derivative of e to the x is going to be e to the x. If we then look at the function e to the 2x and see if that has any effect on the gradient, we'll start to animate to show the gradient. So you'll see it's following very similar path here. But what will happen at this point, you see, is as the gradient increases, because we've had a dilation from the y-axis, so this has actually made it a lot steeper. So the curve has become a lot steeper, so therefore the gradient becomes a lot steeper. Okay, so remember, when you dilate a function a factor half from the y-axis, you're timesing the x values by half. So this is making the exponential function a lot steeper. Therefore, the gradient's going to be steeper. So you'll see at this point here that we know that the gradient here, you see, is going to be actually 2 instead of just 1. The gradient has changed. So when you derive this e to the 2x, what we actually get is a steeper function, which is 2 e to the 2x, okay, because this is e to the 2x, and the gradient, you see, is a lot steeper. So what we've actually got is a dilation from the x-axis of 2. So the derivative of e to the 2x is therefore going to be 2 e to the 2x. Therefore, from working out the gradient function here, we can actually get the rule of the derivative of an exponential. So if we have f of x equals e to the f of x, f dash x is going to equal f dash x e to the f of x.